So we're now going to talk about case study ex3. And case study ex3 is going to show how to multiply and add a bunch of big fractions asynchronously and concurrently using a bunch of RxJava Flowable operators and, most importantly, a bunch of RxJava ParallelFlowable operators. And it's going to use the computation thread pool. And you can find this particular example here in the ex3 project in my reactive Flowable folder in my live lessons GitHub repository. So we're now in my GitHub repository for case study ex3. Here is the ex3 entry point. And you can see this is going to use a parallel flowable stream and a pool of threads to do big fraction multiplication and additions in parallel. As usual, we register a method reference here with the async task barrier framework. And then we run the task. There's just one of them here. And block until it's done. And then the main thread exits. And of course, the reason for doing that is we don't want the main thread to exit, because that's the only thread that's the non-daemon thread involved here. And so we don't want that to exit, thereby shutting down all the background threads or the background thread that's running here. And actually, there'd be a bunch of threads because we're using a thread pool. So let's go ahead and take a look at the test fraction multiplications test method. You can see it basically puts some debugging information here in a string buffer. And then it creates an array of big fractions with a numerator and denominator. It has a local variable called display results, which is a consumer, which just prints the results, taking the string buffer, converting it to a string, and displaying it. And then we have the real purpose of this whole thing, which is to demonstrate a little parallel flowable stream. And you can see the first thing we do is we use the fromArray factor method. And the fromArray factor method is going to convert the big fraction array into a flowable stream. We then take that flowable stream and we convert that into a parallel flowable by using the parallel factor method. We then say, I would like to run all these computations. There's only 4 of them here, but all of them are going to be run in parallel in the computation thread pool, which is the one, remember, that's fixed size, doesn't grow because it's intended for CPU-bound or computation-intensive, not I/O-bound tasks. Then what we do is we don't use RxJava's flatMap concurrency, and we use RxJava's ParallelFlowable mechanism to multiply these big fraction objects asynchronously in a thread pool. And I guess I could probably say in parallel in a thread pool. So it's just going to multiply each of the elements in parallel using the S big reduced fraction, which you can see is just a nice big, whoops, that's the big fraction, sorry. So there it is, big fraction, just a nice big fraction. We then log the results, and when we log the results, you'll see that we're going to print out what thread they occurred in, so you can actually see that these things, in fact, are running in parallel. We then convert the results back into a flowable. So the parallel flowable is turned back into a flowable. And then we're going to take the results and reduce them into a maybe, which is just because there might have been no elements in the flowable, but there were, so we're fine. And then we're going to go ahead and display the results when all goes well. And then the last thing we do here is we return the result of ignore element, which is just a completable that tells the framework, hey, we're done. If we're the last task running, you can return from blocking get, and the main thread can go ahead and exit. So that's what the code does. Let's go ahead and run it. You can kind of see what it does. It's going to go ahead and take those 4 big fractions, and we'll multiply them in parallel. And you can see here a couple interesting things. This is the thread we started out in. And you can see that all these multiplications are taking place in other threads, thread 15, 16, 17, and 18. And then the final thing we do is we print the results in the main thread, thread 18 here, after we add things together, add the results together. So that's the result of the test that demonstrates the use of the computation thread pool to do our conventional multiplication and manipulation of big fraction objects.